Max is trying to eat a wafer. Stop! God. This freaking cat. Also, I brought out my actual mic for this. Isn't that crazy? I finally got my actual mic. But, hold on. Give me 2 seconds. Give me 2 seconds. Okay. Okay, I'm ready now. Alright. What's up, every pony? Today, as you can probably tell by the title, by the way, I'm gonna explain my mic in a second. But as you can probably tell by the title, I'm going to study today. It's going to be quite a boring stream, not gonna lie, just kidding. I'll try to make it as fun as possible. Because what I'm studying right now is physics, and I'm also going to probably do some chemistry homework. And both subjects suck balls. So I'm going to try to make it as entertaining as possible. Maybe not entertaining, I should probably turn the music down. Probably not entertaining, but at least somewhat interesting. Just kind of like last time. Last time I did a study stream, I think I was doing family stress or something like that. It was some kind of psychology class. And I thought that was fun to go over. Plus, that helped me with my project that I had in that class where I had to talk about all that stuff. So I figured that studying on stream kind of helps me actually retain information. Probably because it's kind of like I'm reading it out loud and I'm kind of like teaching, but like not really because I don't know what I'm talking about, especially with physics and chemistry. But today is basically gonna be a study stream. Nothing too special. I was going to ditch the studying and play Overwatch instead, but I figured I have 3 exams that are on Wednesday, and I should probably study for those instead of slacking off and playing Overwatch. However, I am starting to play update on Overwatch, by the way. I'm starting to play comp, and that is awful. I hate it so much. I haven't even ranked yet. That's how much I hate it, because I just hate playing it. Okay, we're gonna basically jump right into it. Just one moment. But yeah, I brought my actual mic this time. I don't know, I'm pretty sure the difference in quality is going to be quite grand. Because I usually use my iPhone earbud mic, my Apple earbud mic, because I'm too lazy to get my actual mic set up. And now I have it, except it's not actually set up fully. The boom arm broke. Like the little screw for the boom arm to like hold it onto the table, it broke. It actually broke a long time ago. But this time it really broke. Like, it broke to the point where, like, I can't, like, fix it. Because last time it broke, I could kind of fix it, and, like, I kind of just kind of made do with it. But this time I really can't. It's, like, unsalvageable. So, that broke. So right now my microphone is just laying on some pillows. Hold on, let me see if I can take a picture of what this looks like right now, because it's really scuffed. It's just kind of sitting there. Hold on. Also, I'm in my bedroom. I would have streamed on my desk, because I finally cleaned off my desk so it looks normal. But I'm too lazy. Also, I've been sitting almost all day at that desk doing other schoolwork, so I don't want to do it again. I want to be in bed. Plus, it's already like 10 p.m. Like, it's already bedtime for me, basically. Also, I don't know why the music... not every time, but sometimes when I switch apps, like, the music kind of screws up a little bit. It's okay. Okay, hold on, one moment. Let me show you what this looks like. I know there's like no one here right now, but I still want to show it. Give me a second. Anyway, whoever's listening, whether it be like right now or in a VOD, I hope you're doing well. I know it's been a while since I streamed. Also, this is the wrong thingamabob. Alright, here we go. Now it's been a while since I streamed. I've made a goal for myself this year to stream at least once a month. Okay, also here's the picture if I can even... Hold on. God. I hate that it's so big. Every time I try to show a picture on stream, it blows up to like, oh god, now it's like completely gone. It blows up to like ungodly proportions and I can't. Come on. Yeah, man. Oh shoot, did I make the... Oh, I think I made the output 720p. Sorry about that. It's okay, I don't think you guys will notice anyway. Here's what my setup looks like right now. It's just sitting on top of stuff. My charger's like stretched out across the room in the back. Also, you can see my Chromie bag. I got my hard drive just sitting there. My microphone just sitting there. Also, this cord for the mic. Oh, wait, you can't see my mouse. Hold on. You will see it if I do this. Nope, you won't see it. Okay, wait. Wait. Pause. Everybody pause. Pause. Okay, go now. Paste. Oh my god. It's annoying. Now we have to go back. We have to go back here. Go here. There you go. Now I have to do this all over again. Okay, whatever. What the heck was I even doing this for? I forgot. I forgot. Oh my god. This is a mess. I really need to get my stuff together. I almost cursed. Hold on, everybody. Hold on. Okay, you see this right here where my mouse is? Can you even see my mouse? I don't even know if you can see my... Oh yeah, you can. Okay. This right here is like super bent to the point where it's gonna break. Like if I move this mic just like 1 inch any direction, it's gonna break. Also, I don't even know if... Is this even my mic? Uh-oh, it's not even my mic. Is this my mic? I can't tell. Was I talking that entire time without even using a mic? Oh god, oh god. Oh man. Not going good. Now I need to check. Oh my god. Also, I'm really glad I can stream today. I've been itching to stream for a while, but my internet has been so bad. Okay, hold on, let me test. Let's see if this is the right mic. I can stream today. Okay, yeah, it's the right mic now, thank god. Oh my god, man. That was freaking hard, man. Okay, yeah, it's the right mic. Shut up, me. Alright, there we go. Okay. I think we're ready to actually start now. This has been so scuffed. I want to check if the bot's even here. Is the bot here? The bot's not even here. Alright, guys. You know, I probably should have done this, like, way before. But, you know what? It's fine. Oh, god, I love this song. No one look. Don't look, guys. Can't see the trade secrets here. Is music loud enough? Okay, it looks fine. Actually, it looks too loud. Right there. Okay. The modding bot's not even here. Like, there's just so much that's not ready. Oh my god. Lie between mother and child. There you go. God. Sorry. This is so scuffed. I don't know why the bot always has that $sign. Can you tell that I'm, like, really trying to kill time here? Because I really don't want to do this homework. My laptop isn't even charging! Oh my god. It'll live. Okay, when it's like starting to really die, then I'll charge it. Oh my god, it's not even charging. Man. Where is it? Cloudbot. This is a lot of stuff. Here, guys, this is how you stream. Why does it... Ugh. Just grow up and save you after all. Let's just friggin' study. I'm really procrastinating. I'm so sorry. Okay. So, the thing is, okay, I have a huge to-do list for today. And you know what? I'm gonna write it down. Write it out so then we're all on the same page. Ready? Because I've been kind of slacking for a while. So I have a lot of stuff to do. Okay, here's what we need to do. For physics, we need to read. I don't have to read these. Like, I'm kind of just mostly gonna skim through them because I kind of already know what I'm doing, but we need to review it because it's for my upcoming exam, which is next week. So we're gonna read chapter 25, which is about mirrors. Then we're gonna read chapter 26, also about mirrors. Then read chapter 27, also about, I think it's actually about lenses, I'm not sure. Then we need to do the homework that's due Sunday. So I need to do it like right now because it's gonna be due tomorrow. I forgot today's Saturday. I thought today was Friday, man. Okay, whatever. Alright, then we have chemistry. These are the two that I'm really like falling behind on. It's just because there's so much freaking work to do and it's just like, anyway. Okay, we're gonna finish the worksheet because I haven't even touched that yet. And then we're gonna do all the Alex work, which is stupid. I hate Alex so much. It's basically like this website where you have to like do like problem. I really hate it. It's an introductory chem class. I'm super bad at chemistry. But whatever. Did I even? Oh, you know what? I need to finish the lab abstract. That will take the least amount of time. I think I can actually knock that out quicker than the other ones. Okay, that's for chemistry. And then we have pagan culture, which is like I have to read like 1,000,000 pages of that. I don't even have the book. I don't even have the book. That's how badly behind I am in that class. It's just such a boring class. Like I thought it was gonna be really fun because you know pagan culture and Roman history and stuff like that. That sounds interesting, right? It's not interesting. It's really boring. I hate it so much. Or at least it's not boring. It's just that like my lecturer is really boring. I really can't. It's like 3 hours to go through, and it's just really annoying, and I just can't stand it. Anyway, then for biostatistics, we're gonna watch all the lectures. I might actually do that first because that I feel will take the least amount of time. Watch all the lectures and then oh god, my brain not working. Do I have homework due for that class? I think I do. Oh, yep, I do. Okay. Do homework. Which is due on Tuesday. Oh my god, I have so much stuff. Okay. Oh, books plural, by the way. there's 2 books. Actually, I think there's 3. God, jeez. Okay, watch all lectures, do the homework, and we're gonna finish the lab assignment, which is just coding, and that sucks booty. Alright, so let's freaking do this. Not excited. I think we're gonna do biostats first. That seems like something that like we can all be engaged in. And by we all, I mean me and probably like the one other person here right now. I don't know. I can't. I don't usually check my viewers. Okay. I don't know the... Okay, we have this like... That. We have that. Right? Give me this. I'm super behind on this. I have not even watched the... Don't be like me, guys. Okay, we're gonna do this first, though. That really seems like it'll take the least amount of time. All right. So, listen. No. Listen. It'll be fine. It'll be fine. It'll be fine. We'll live. I can do it. I can cram a lot of stuff into a few hours. Do we hear this? We do hear this. Okay, good.
Statistics uses math, but the purpose
All right.
and goal are what sets them
Dude, my biostat teacher is honestly pretty freaking awesome. I love him a lot, and I love his lectures. I just don't have the time to go to them because I have work on the same days that the lectures are in, and I scheduled it so that my work schedule would have a break from like 2 to 3, which is when the lecture is. But then, like, by the time it hits 2 p.m., I'm, like, so exhausted from work, or mentally exhausted, not actually physically exhausted. I have an office job. But I'm, like, mentally exhausted that I just don't want to go to the lecture. And plus, it's, like, a 10-minute walk to get to the lecture, and I'm like, I don't want to take a 10-minute walk. Anyway.
Statistics is trying to use
okay, I did this all...
To do more, the inferential
I do remember a lot of
how
these.
do we measure these things? By the number of species?
Also, I love these lectures. Also, okay, first of all, these are like online lectures, and then he expects us to like watch these before the real life lecture. But I haven't done any of that. But I still kind of understand what I'm doing, sort of.
Species, and whether the life is enjoyable or not.
Okay.
Strengths of beliefs are often measured on a 5 or 7-point scale.
Yeah.
What does that really mean? Understanding which metrics are the best ones to use
okay, there you go.
at hand is an important part of statistics and experimental design.
Yeah, sure.
Another aspect of choosing metrics is what kind of numbers and values to work with. Some types of values can lead to equations.
Okay, maybe we should start with the beginning.
Uses math, but the purpose and goal are what sets them apart. Statistics is
Intro to statistics. What else do I have for these?
We can measure.
Summary statistics. Okay, I did that. What in the world is this? Ooh, I actually did do that. Wow, this is the day I went to class.
Descriptive or summary statistics to represent a larger set of numbers. For example, imagine that we have a bunch of eggs.
But these are empty.
That is, how much do they weigh? We could measure all the eggs, but then we have
okay, anyway.
different numbers, and it's hard to really...
This is all I watched up to this point because obviously my notes reflect that.
Instead of keeping track of all the individual
oh god, guys.
We could calculate the average weight of the eggs. We can then
make this
describe the
louder.
sizes of our eggs by talking about their average weight.
Does it? If I make it louder, does it? Oh no, it doesn't.
Which we can represent with a few different
okay, cool.
statistics. There are also more complicated aspects about sets of numbers that we can describe with other summary statistics.
Sure.
For example, are there a few much larger eggs or super small eggs that are different from all the rest? There are descriptive values that we can calculate to describe these things. When we use our descriptive statistics in this way, we're helping to simplify the overall situation so that we can understand it better and describe it to other people.
Okay, cool.
Descriptive statistics is therefore the aspect of statistics in which the purpose is to describe or summarize a set of data values.
Oh my
When
god.
we make data figures to show our data, this is also a form of descriptive statistics, conveying a sense of what the data looks like. The details of how to calculate good descriptive statistics and how to make good figures are topics we cover in other videos on stats examples. Another aspect of descriptive statistics is choosing the right metric.
Okay, we're gonna make this a little faster because I'm starting to get bored already.
On the left are some straightforward metrics that are used all the time in the sciences. Values like length, mass, temperature, and speed are well defined. What they measure is obvious, and we often have a direct use for the actual numbers. On the right are values that are less straightforward. Do we really care about blood pressure itself, or do we measure it because it's related to the risk of heart attack, the real value we care about?
Okay. Okay, maybe I made a mistake too fast now. I can't understand anything. Man.
How do we measure these things? By the number of species or by using lifespan? Both of these choices are missing something. The variation in types of species and whether the life is enjoyable or not. Strengths of beliefs are often measured on a 5
What is that glitching?
Scale,
do you see that?
Really mean? Understanding which metrics are the best ones to use for the question at hand is an important part of statistics and experimental design.
Okay, cool.
Another aspect of choosing metrics is what kind of numbers and values to work with. Some types of values can lead to equations that are easy to understand and work with, but others can be
integers.
For example, working with integers, that is whole numbers, decimal numbers, and proportions usually works well. On the other hand, fractions and ratios, while often being nice for descriptions, can end up having some terrible mathematical properties when we try to do more complicated things. If we just want to describe things, these are all fine. But if we want to do more, the inferential statistics I'm about to talk about, certain metrics work better than others.
Okay.
The second type of statistics, inferential statistics, arises from the fact that we usually don't just care about the set of numbers we have. We usually have a large system we care about, and only measure a subset of the values.
Why does it do that?
We have all the numbers for the smaller subset.
Stop.
And use descriptive statistics to describe that subset, otherwise known as a sample.
Okay, inferential statistics.
To describe the larger population these values came from, we have to make some assumptions or estimations, otherwise called inferences. These terms I'm using, sample and population, are
oh my god, I missed literally all of that.
But if we want to use that for statistics I'm about to talk about, certain metrics work better than others.
I hate
The second type of statistics, inferential statistics, arises from the fact that we usually don't just care about the set of numbers we have. We usually have a large system we care about, but can only measure a small subset of the values. We have all the numbers for the smaller subset and can use descriptive statistics to describe that subset, otherwise known as a sample, perfectly. But if we want to use that data to describe the larger population these values came from, we have to make some assumptions or estimations, otherwise called inferences. These terms I'm using, sample and population, are technical terms in the field of statistics.
Oh my god.
The population is the overall system of values that we care about. We'll call its descriptive statistics population parameters. We can almost never measure these population parameters directly. Instead, we calculate the descriptive statistics of a sample from the population. We then use these statistics to make educated guesses.
Oh my god. Statistics from the sample to make inferences about the...
What if we wanted to know what type of eggs to expect from a giant flock of chickens?
This is really hard for me to follow because I'm usually like a visual person, and so the best way for me to learn is through like reading. So him just talking and like these slides being so simple is like, oh my god. That's why I turn on the captions because it kind of helps, but the captions are going too slow.
Of some eggs from some chickens, and then assume that the rest of the chickens will lay eggs that are similar. We may be required to use this approach for two reasons. First, measuring every egg from every chicken in our entire flock might be too much work. Also, measuring eggs today wouldn't allow us to
statistic
unless we conceptually use that set of today's eggs as a sample from the population of all sets of eggs that we will get now and in the future.
Can you hear my typing, by the way? Hold on, let me test this.
Of course, no sample is guaranteed to perfectly match with the population.
You could earlier when my mic wasn't right, but yeah.
Identical populations would give us two very different sample averages and make different predictions about the population. Because of this, we can't assume that the population
okay, blah 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 blah. Yeah. Whoa, why is it doing that?
Likely to look like. For situations like
How about this? There you go.
For example, if our sample average was 10, then we would say that the population average is probably near 10. But if the sample average was
blah blah blah. Okay, let's do that.
What I just mentioned, having an idea about a population and seeing if our sample data confirms it, brings us to the second aspect of inferential statistics. In this approach, we pose a question about a population.
Wait, what was the other one? Okay,
In this
great.
approach, we pose a question about a population, or more than one population, and use the statistics from our sample.
I was what because earlier I was typing on my keyboard, obviously, and I saw like the wavelength. I mean, the wavelength of the audio like going up, and I was like, "Oh, why is it going up? Surely I don't type that loud." And now I know why. It's because I'm using the wrong mic. I swear before I started streaming, I put the right mic. Ah, whatever. I mean, at least I'm doing it now.
We calculate the appropriate sample statistics.
Yeah, blah 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 blah.
The average sizes are the same, so we would calculate some averages. But there are lots of other types of questions we may be interested in as well. Then we calculate the probabilities
Oh my
of
God.
sample statistics if the answer to our original question is yes or no. Then, based on these probabilities, we make a decision about the probable answer to our original question.
Statistics. Why?
An example with two populations of eggs we're interested
It's too fast. Stop.
We calculate some averages, but there are lots of other types of questions we may.
Okay, this is familiar because this is what we do in lab.
We calculate
So
the probabilities of seeing our sample statistics if the answer to our original question is yes or no. Then, based on these probabilities, we make a decision about the probable answer to our original questions about the population or populations. Let's think about an example with two populations of eggs we're interested in. We may want to know if the average sizes of eggs from the two populations are the same. If the populations are too big to completely measure, or if we're trying to make predictions about the future, then we'll be using samples from these populations. So step 1 is to collect some samples and measure the eggs. Since we're interested in the average size, we'll calculate the average for each sample. The chance that each sample's average exactly matches each population
I'm losing my mind here right now.
very low, however.
I'm literally so bored.
By random chance, the averages will be different even if the populations have the same average.
I just got a notification on my phone saying, it's time for bed. No, it's time for biostatistics.
Population averages are the same. In other words, if the two populations really do have the same average, then the samples should be similar, but we don't expect them to be identical. How similar should they be, and how different is too different, is the question. Statistics uses ideas from probability math to calculate this probability. Then, once we have that probability, we use it to answer our question. If the probability of seeing two sample averages...
Okay, yeah, I got it. Yep, okay.
But there are also tests for averages.
Okay.
For example...
Okay.
We just looked at was asking if two populations have the same average. We looked at an example of the sizes of eggs in two populations, but there are also tests for more than two. For example,
averages, I forgot the other one.
Average variability.
Averages, variability.
But we might also care about
blah blah blah.
Example, is the proportion of blue eyes
Proportions. I'm just making sure, because if they give me a free response question and they're like, oh, what's this for, then I need to know, you know what I mean? Correlation. What was called correlation? Blah 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 blah.
We answer this question with probabilities. For all of our tests, we do our sample data if things are just random. If these probabilities
okay. Pause. Okay. Pause, because this is actually something important, or it sounds important. When finding evidence for non-random patterns, probability indicates the patterns were probably not random. So differences, so the pattern is probably real. Then high probability indicates... The reason why I say this is important because I feel like I've heard this in a lab sometime and then I didn't know what the heck was going on. Anyway, indicates pattern could be random, so evidence is lacking to decide if the pattern is real. Okay, blah 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 blah. Okay, let's go. Boo boo blah boo boo blah. Oh my god. That's a lot. Hypothesis testing.
Here's where I mentioned that full inferential statistics is more complicated than...
Oh my god, I don't want to even... Do I really have to know all this? Oh my god. Oh my god. Oh my god. Well, That's a lot of stuff to know that like I just don't really want to know about. This is a requirement for my major, but I can't see myself ever using specifically biostatistic. I took statistics in high school and I loved that class so much, but biostatistics, like, this is hard. It's okay. It's fine. I'll live. All right. Bayesian stats. Okay. Wait, hold on. This is still inferential statistics. Oh my god. Just never ends, this thing. Okay. Hypothesis testing frequencies. Okay. Make decisions based on probability. Oh my god.
What I've been talking about is something called hypothesis testing,
Okay.
which is more properly known as the frequentist approach to statistics. It's the kind of statistics that's been around the longest, it's the easiest to understand, and it's what all intro stats courses focus on. If you're taking your first stats course, you'll almost certainly be doing just descriptive statistics and frequentist.
Okay, I do remember this part. I remember him saying that we don't have to know all that. Okay. Next.
Welcome to this video.
What's up, dude?
To summation notation. In particular, it's how summation
notation. All right, this one. Boom.
So it really is all about the rows and the columns.
This one I was really having trouble with because, like, what the heck? What am I looking at? I remember watching this. I have watched these like a little bit, but I just remember watching this one specifically and being like, "What is going on?" Okay.
Notation is used in math and physics classes, as shown here.
Okay.
The symbol
yeah,
sigma,
I can see.
Which looks like a large E.
Yep, I know what summation is, I just don't understand, like...
Below the symbol indicates values for the first term and for the last term.
Okay.
The index letter indicated, in this case...
Okay, wait, pause. Okay, pause. Okay. So this, he's saying, okay, number on top of the sigma sign. Sigma? It's just like the character from Overwatch, bro. Oh my god. And he's a physicist. Oh my god, it all adds up. He's so cool. I love Sigma. I wish that his main primary fire wasn't so awful, but it's okay. Okay, wait, hold on.
Below the symbol indicates we're going to sum or add up the terms to the right of the symbol. The text above and below the symbol indicates values for the first term and for the last term.
Okay.
The index letter indicated, in this case the letter I, is understood to increase by 1 for each term. So in the first example, the sum indicates we're going to start when the value of I is 1, as shown below the symbol. We will then add to the next term, which the value of I will be 2.
Okay. So... what? Oh, okay. Okay, first just the index letter indicates the first... Index letter? Index number indicates the number to start with. Because in this case, oh my god, I don't even want to look at that. 1, 1, 2, 2. Oh my god, what in the world? Okay, this one is saying... Okay. What? Index 0. This is gonna be 1. Isn't it gonna be negative? No, it's just gonna be 1. 1 for 1. This equals 0 for 1. Okay, that's right. Yeah. What the heck is going on here, bro? I need to friggin' lay down for this. Oh my god. My legs hurt already. I had a long day. A long day of dealing with the construction that was outside for like 8 hours straight, and then like, oh my god. Okay. If you hear me struggling, it's because all my joints just really hurt. Okay. Okay, and then you're saying it's gonna increase by 1. What? What? Okay, this turns to 1. This can be negative 4 over 3. Yeah. Okay. Then this 5 indicates when it stops. Okay, got it. Wait, does it? Okay, no, got it.
3, and so on until we get to the last value of 6, which is shown above the symbol.
Okay, got it.
The second example.
Listen, I did this like a long time ago in high school. I just don't remember any of it. Index number, separate. Well, but it's really hard to type when I'm laying down like this. Well, number on top of the sigma. Sigma sign indicates the number to end with. Okay. I know most of that. Okay, this is when it gets freaking weird because I'm just like, oh my god. I just don't understand the way he explains. Okay, let's just watch.
Data, when we're doing statistics, is in data table information.
Yeah, I know what table tables are.
Sure you don't accidentally.
Yep, I know that.
For example,
okay.
Rows data in your calculations. Horizontal line.
I know what rows are. I know what columns are.
In a subscript.
This is when I get confused. We identify any value in the data table by specifying row and column. Most common is row and then column. Okay, so it's saying 2, 3. It's the second row, which is this one, then column, third column. Okay, good. Okay, I got that.
And x1, 4.
Alright, watch this freaking practice. Alright. This one, third row, second column, 8. Fourth row, first column, 1. 8, 1. Then first, fourth, 8, 1, 4. Alright, is am I right? 8, 1, 4. Okay, great, I'm right. Oh my god. Okay, once you have a bunch of data, don't care. Okay, let's go. Keep going, keep going, keep going. Describe calculations across row and column. I and J columns are dummy variables changed in the range specified below and above the system. Oh my god, I'm gonna kill myself. I and J aren't row and column. The order determines it. The letters are okay. Ignore what the letters are. So, okay, okay, got it. I never pressed play, but okay, buddy. In truth, sigmas use more. So, okay, don't care about whatever that symbol is. Okay, so what it's saying. Okay, I's, forget what I is. It's just saying 1, 1. Okay, 5. Then saying, next is 2, 1, then 3, 1. 2, 1, 3, 1. 5 plus 3 plus 2. Okay, got it, got it. Okay, yes, I know what that means. Okay, pause. Alright, so it's saying 2, 2. 2, 2. We have 5. I'm ignoring all that, by the way. 5. And it's saying 2, 3, 7. Then it stops at 2, 4. 2, 4, 9. 5 plus 7 plus 9, 4. Okay. This one, 2, 2, yes, yes, we just did that. When you perform my calculations using one more than the double summation, oh my god, this is where I get really confused. Best approach is for comfortable is carefully without using parentheses. Okay, so, I don't, oh my god, okay, let's see. Like, this just don't be making any sense to me. Like, what's the parentheses for? Is it saying that we're trying to find the sum of the sum of... That makes no freaking sense. Okay. Equals... Oh my god, I'm gonna cry. Okay, I think I understand. So... It is saying that. It's saying the sum of xij. So... Okay, put those in parentheses. So I wish they made this smaller. I think that would have been more interesting. I mean, interesting. Easier to understand if they made this in parentheses smaller. So it kind of indicates that we're finding the sum of this instead of like, it looks kind of like you're multiplying it. But anyway, so we're using I here. So what? So what's a J for? I thought we were going to put J in there. What? Okay, so I understand that, but then what does... Okay, great, thanks, dude. Alright. So, it's gonna be... Oh my god, kill me. Can I see what you... Wait! Frick! What? It's the same one. So... Oh my god. Kill me. Kill me now. It's saying... Give me 1 second. How is it not just... one... Oh, I get it. Okay. It's saying 1... It's gonna be 1, 2, then 2, 2, then 3, 2, right? Let me see this again. 1, 2, 2, 2, then 3, 2. Okay, these 3, right? But then how do you get these freaking rows? What do you mean? What do you mean by that? What does he mean by that? This is columns 2, 3, and 4 of rows 1, 2, 3. How do you get columns whatever? I only got the freaking rows. Is it just like is it just like when you're using what? If J goes
and j going from 2 to 4.
Hold on.
Calculate each of those 3 summations where j is changing separately.
Okay, hold on.
The index in the first summation is shown in those 3 terms on the right. We can go ahead and replace the i's in the subscripts with numbers 1, 2, and 3, and then calculate each of those 3 summations where j is changing separately. Let's look at an example.
Wait. Oh, I see. Okay. No, I see. Okay, so it's saying that this is gonna be 1, 2, 1, 2. It's gonna be 1, 2, then 2. Wait. 1, 2, then 1, 3. Wait. Yes. Okay, it's gonna be 1, 2, then 1, 3, then 1, 4. And then it's gonna be 2, 2, 2, 3, 2, 4. It's gonna be 3, 3, 3, 2, 3, 3, 4, 3, 4. Whatever, right? So, okay. I freaking got it. Okay, makes sense. My god, that's such an awful way to explain it.
We can think about this as the summation
I'm sitting up now.
1, 2, and 3, the first summation, for columns 2, 3, and 4, the second summation.
It's literally such an awful way to explain it, but whatever, it's fine. Mind. Yeah, then you add those all up. Okay, I can do that. That's easy.
For each of those terms, we then have the summation for the dummy variable j.
Such a stupid way to explain it. I'm so mad.
3, and 4.
I think I moved my mic a little bit. I'm not sure if I unplugged it on accident.
The summation based on
Okay, it looks good.
Into those 3
Let me check though. I'm nervous. Let me check. Okay, we're good.
And you can see that I is changing for each of them.
Got it. Yep, I know how to do that now.
X2, 4.
Thank freaking god.
For example, the left pair of summations are the same because the i's and j's have been swapped. For example, the value of the x.
Didn't we just do this?
Using our this pair of double summations are not the same. If you imagine what the rectangles of data look like for those cases, you can see that they're not the same. Okay, so what do we use all this for? The answer.
Okay, wait. Pause real quick. Go back. Okay, so it's in parentheses. Okay, that makes sense.
Like equation, the mean is represented by a bar above the x. Using our double summation nomenclature, that's equal to the sum for I from 1 to 2 of the sum for j from 1 to 4 of x I specified.
Yeah. Okay. Got it. Okay, guys, we're doing great. To be honest, told you it'd be fast.
Double summations can be confusing.
La di da di da.
By doing some examples. So let's.
This is just examples. We are already by we I mean me. I think I've already got it. So let's do summary statistics. Guys, we're speed running right now. Oh my god, I'm so good.
The type of values that are used when doing statistics. When we're conducting a study, we care about the parameters of a population. That's all the individuals.
Okay, pause real quick. Go from beginning again.
Let's look at the type of values that are used when doing statistics.
I know how to.
Okay, whatever. Study, we usually care about the parameters of a population. That's all the individuals or items of interest. But we can't measure all because it's not feasible or practical. We therefore usually measure the values for a subset and calculate statistics of a sample. And our sample statistics are therefore estimates of the population parameters, as indicated in the diagram here.
Oh my god. Oh my god.
We take a sample. Statistics, and then use those statistics to estimate the population parameters. So we then need a way to summarize the sample or population.
Yeah. Okay, we need to summarize it. Yeah. Okay, boom.
And third, we sometimes want to know how the distribution of values compares to others that have similar locations and spreads. First, let's look at statistics of location. So here we're asking the question, what is the typical value or the average? The first important thing is to realize there is no the average, there are 4 different averages that can be calculated.
Mid-range? No one calls it
The
mid-range.
sum of all the values divided by the number of values.
Is it called mid-range?
The median, which is the value that's in the center of our
Oh.
data set, with half on each side.
Is it really called mid-range? I've never heard it as mid-range.
Between the smallest and largest value. And the fourth is the mode, which is the most frequent or common single value. You can have more than one mode.
Okay, the only one I can never remember the difference between is median and mid-range. Okay, median is value in center of all data. Mid-range is value in center from smallest to largest. And then I know what mode is. It's just the most common one. Okay.
If more than one value are equally common. The first two are commonly used, and it's all with all the values.
Yep, I know how to do that. I already know. Yes.
Is what
blah, blah. Okay.
And a major property is how robust, that is consistent or resistant to the effects of randomness, are the values.
God, okay. What? How robust, consistent, or resistant to randomness. Okay. Okay. Robustness? Is that a thing? Is that a word? Robustness? It is. Alright. Robustness. Sounds like tobuscus. Robustness. Indicates how consistent or resistant to randomness a value is. In extreme cases, what? Median and mode are robust when calculated from repeated samples from a population. The mean and median are robust. It seems like the median's always robust. Awesome.
So one way to think about this.
How resistant? Wait, those are the same. Okay, how does robust mean in stats? Does statistics with good performance were data drawn from a wide range. Okay, that doesn't answer my question. Robust. Okay, robust. Okay, we're talking about resistance. How resistant to randomness. So it's saying that median and mode are most resistant to randomness. Mean can be okay, that makes sense. Okay, that makes sense. Yes.
In the presence or absence of outliers.
Because it's like if you have like some outliers, your mean is going to be changing quite drastically. But your median and mode are probably going to be the same. Okay, that makes sense. Makes sense. Maybe not the same, but it's probably going to be most stable or whatever. Yeah. Okay, spread.
Variability or dispersion. And now we're asking the question, how variable are the values? So we'll look at 6 different spreads. The first is the range, which is just the distance from the smallest to the largest. Second is the interquartile range, which is the width of the middle 50% of the values. And then we'll look at 4 values that are all based on the sum of squares, which is the sum of
pause. I need to know all this. I keep forgetting every one of this. We did this in lab, and I was just like I knew theoretically I knew what I was doing, but I also just did not know what I was doing. So we're gonna have to remember this. Interquartile, and by we I mean me. Interquartile range, width of middle. I know that interquartile range is like quartiles, so I'm just gonna write that instead of what he just gave us. Some squares is the sum of squared differences from the mean. I have no idea what that is. Variance. We use this in coding. So that's why I really need to know them, because one of the exams I have is related to all this, and I still don't know what I'm doing. Okay, square root of variance. I'm just gonna use short. Coefficient of variation See relative to mean. Okay. I know what interquartile range is. We have Q1 and Q3 are the ones I need to know the most. Range, okay. Okay. Got it. Got it. Oh.
In this case, it would be 14 minus 2 is a range of 12. And the range is not robust because it's only using 2 of the values. The IQR, which represents the middle of 50%, in this case you can see it's encapsulating the middle 3 out of the 6 values, is more robust because it uses quartiles and it's related.
Do you really have to? I've never heard robust whenever we're doing lab. God.
Here are the same statistics of spread.
Yeah, whatever.
Into 4 equal regions.
Okay, IQR equals. It's oh yeah, I got it wrong. It's Q3 minus Q1.
And then we have Q1, which is the first quartile, and that's going to divide the bottom half into 2 equal-sized chunks. You can also think of this as being placed at the 25% spot.
Yep.
Q2 is our median, placed at the 50% spot.
Yep.
It's divided. You can see.
Okay. Blah 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 blah.
The method's going to ignore the shape.
Oh my god. Okay, symbol method. This method ignores the shape. Oh my god, I don't care. Okay. Do I really have to know this? Oh my god, I'm gonna cry if I actually really have to know this. Simple methods method ignores shape and distribution, focus on examples. Okay, fine, we'll write it down, why not? Just in case. Calculating quartiles. Arrange values in order from smallest to largest, okay. If n is odd, median is center value. If beat is even, median is mean of 2 middle value. Okay, I understand that. Then we have. Oh, that's not even that complicated. For the first 2 steps for each half of data set. That's not even that complicated. I don't know why I got overwhelmed by that, but okay, let's go. Let's freaking go. Okay, other method exists because it's different. I don't care. Okay, if there's no, don't care. Don't care. All right. Medians and quartiles are used for describing, but these are used in statistical stats. The math. Don't care. Let's go. Okay. Yeah. Straightforward. Blah blah blah. Okay. Sum of squares. Speedrunning this for real. I really don't like watching lectures. Can you tell? I'd rather prefer reading. See, earlier when I was doing this, I was just gonna read, but I was like, this is gonna take the least time, and now I regret it because I really hate watching lectures. Anyway, sum of squares, foundation of variance, extremely prone to being inflated by outliers. Therefore, it's not robust. Oh my god. I'm using the knowledge that I just learned. Whatever. Okay, variance is always positive. Estimate of population variance using a sample often underestimates, therefore, different denominators used to create an unbiased estimate. Okay, let me read it again. The estimate of a population variance, okay, using a sample often underestimates. Okay. Estimates using population variance often underestimates. Okay, different denominator often used to create unbiased. What does that mean? Okay, so I don't know what that means, but I'm gonna write it down anyway because it's probably important. Alright, next. Standard deviation has okay. Wait! Use the same units as original data. Can be hard to interpret. Why is it hard to interpret? No one knows. Alright, let's keep going. Coefficients, always positive. I'm gonna highlight these because in case I get anything wrong or something like that, then like it's important to know. Actually, I'm gonna no reason at all. I just listened to that song recently. Okay, I need another name for mid-range and stats. I swear there's another. Oh, I guess there isn't another. Midpoint. That's it. I think that's what I was using. I mean, remembering. Pew mew mew. Pew mew mew. Mew 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 mew. Pew mew mew. I was listening to that song, and I was also listening to He's in my heart, he is in... I forgot the lyrics. He's in my eyes, he is in my ears, he is in my blood, he is in my tears. I just sleep, for I just threw out the love of my dreams. He is... What was it? I can play that song on guitar, actually. I'm so tall, can't get over me. I'm so low, can't get under me. I must be all of these things, for I just threw out the love of my dreams. He is in my eyes, he is in my ears, he is in my blood, he is in my tears. I breathe love, I see him every day, even though my love is on the way.
And this puts the variation into context. How variable is the data compared to the typical value? It's often used as a descriptive statistic, it's not particularly common, and it's rarely used in statistical tests. It's used enough, however, that you should be familiar with it. Before we move on to the discussion of the shape statistics, there's something you should be aware of. There are two different equations that can be used to calculate the sum of squares, as shown in the top right of this slide. There's the summation of the square differences, which is fair.
The only two equations that can be used to calculate the sum of squares. One is easy to understand and one has a blah blah blah. I don't care. I don't care. If I don't need to memorize it, then I don't care. Okay, this is what I need to know. So we have shape is measured by skewness, asymmetry. Then we have kurtosis, which is kind of like, oh, is it leaning on one side, or is that what it is? No, kurtosis is the peak. Okay, peaks / tail thickness. I forgot literally all of that. Okay. I had a screenshot of this somewhere and I completely lost it. Anyway, so now I have it again. Alright, negative value tail to the left, which is known as skewed left, which is really stupid. It should be the other way around, but whatever. Value of 0, Zio is Neo, is like balanced, balanced as symmetrical. Okay, and then we have positive value, which is tail to the right, and it's like, oh my god, it's skewed right, which is stupid once again because it should be the other way around, but it's okay. Blah 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 blah. Okay, this is also important. Platypus, platykurtic, values. I don't know what to call it. Or I'll just put it like that. Platykurtic, has a kurtosis less than 3. Oh, like a heart. Less than 3. It's like a rounded curve. Lots of space under the line. I don't know how to explain it. Then we have thing that I can't see, mesokurtic, which has a kurtosis that equals 3. And it's like pretty average sized curve, pretty normal, cool. And then we have leptokurtic, which is like the kurtosis is greater than 3, and that means it's like sharp, pointy curve. Ew, gross. That's exactly what I'll put. Hi, Minkin! How long ago did you say that? Because I haven't looked at chat in a while.
The third power.
Hi! We're speed running statistics right now. I know I said I'd do physics and chemistry, but I don't want to do that yet. Because that is boring. What's it gonna read out?
Anio Jannies, Anio A, Anio Jannies, Anio A, Anio Jannies, Anio A.
Anio, Janny, Annie. Thank you. 13 months? Oh, your streak broke. I'm sorry about that. But 13 months is still insane. Thank you so much, Minken, for the Twitch prompt. Thank you. Thank you, my number one biggest fan. Thank you. 13 months. That's kind of insane. We've known each other for more than a year now. Wow.
Or consistently too small.
Blah, blah, blah. Okay, we're skipping all that. I don't care.
Let's look at...
And these are examples. I don't care. Okay. I'll get back to that someday. I don't know if he's going to give us an equation sheet. I really hope he does. Because God knows I'm not memorizing all those equations. Okay. Summary statistics. Didn't I literally just do this? Or delete you? What was this? Wow, guys, I went to lecture that day. I skipped week 3, but I went to lecture that day. What week is today? Today's week week 5 now, but we're gonna say 4. Alright, we got it says 4 right there too. We have probability. I love probability. Probability. Okay. I love probability. I'm pretty awful at it, but I still love it. Oh yeah. We have okay, blah 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 blah. Alright. Assignment due. I didn't do it. Oopsies. And then we have this, which I can do.
Welcome to this
Alright. So here's how we start notes. We do the date. Where's my mod badge at now? Who knew that being mod meant you just have to be subscribed for 13 months? Also, I need to charge my laptop soon. Okay. We do this, and we do video lectures. This one is Intro to Probability. I like probability because it's the easiest thing for me to understand. Because I feel like everything else in statistics is really boring, and like I just don't care about it, but then probability is there, and I'm like, ooh, gambling. Anyway, I think I'm gonna, should I go, you know, when it notifies me that I need charge, and then I'll do it. I don't know why it's not charging. It's literally plugged in. You know, I'm gonna check right now, actually. Why are you not charging? Why are you not charging? Why? He is in my eyes, he is in my ears, he is in my blood, he is in my tears. There you go. The plug just wasn't plugging. The plug wasn't plugging. Ow, my freaking everything hurts. I'm gonna have to adjust my position a little bit. Also, 1 more hour till Jackbox. I don't care how much work I get done, we're playing Jackbox today. Or we're playing something today on stream because I don't like doing study streams or I don't like study streams where like there's nothing at the end, you know what I mean? Which is just studying, because I find that very boring to watch. So I like having a little reward at the end for myself. So my reward for the end today is gaming. I'm gonna have to scooch over a little bit because I hate streaming from my bed. I hate streaming from my bedroom, but it's the only place where it's like closed off. You know what I mean? Also, I just disconnected my hard drive on accident. It's the only place where it's closed off and like I can talk decently at a normal volume without feeling embarrassed that I'm making too much noise. So, alright. You're coming with me. Hi, microphone. Hey. Hey. God, it just keeps opening. Stop. I don't know if the charge is going to reach all the way here. Oh, it will. Of course it will. Alright. Pause. Everybody pause. Everybody calm down. Okay. Where'd my phone go? Alright, Grandma's in bed now. Jackbox 3. I'm sorry it's so late for you. Sorry. Okay, put the mic. Where should I put my mic? Should I put it right here? I don't know if this is too loud. It probably is a bit loud, but it's whatever. Okay.
And foundational equations used to calculate
I'll put it right here.
The channel has other videos with walkthroughs.
Actually, I'm gonna put it. Is it too loud? It probably is really loud.
First things first, When we're thinking about probability, we consider the probabilities of events within sample
I'm gonna
spaces
put
of
this.
possible outcomes. The technical term event describes the outcome
Put it right
we
here.
focus on
Is that
within a
good?
sample space, which is the set
Feels
of possible
nice.
outcomes. The diagram shows
I don't know if it is
that
nice,
the
but it
event
feels
is actually
nice.
a subset of all the possible outcomes. And when
Right
we
there,
write about
resting on my
probabilities,
arm.
we use the text P with a capital A in the parentheses
A lot of my
represent
ears,
the
I'm sorry.
probability of the event.
I think this should be better.
We read this text as the probability.
Okay, yeah, I know how to do
C,
probabilities.
to change the complement in
Yeah.
numbers.
I know how to do most of this because I love probability, like I said, so... Alright. Complementation rule states that the probability of A plus probability of... that little symbol means not A, but I can't write that down with my keyboard, so better. Yay! So we're gonna do that.
Which is an example.
I'm thinking, actually... Please ignore what we were talking about before this. Wanna play Roblox in like an hour and a half. Smile.
Of the complementation rule. This
Hi,
rule
Matilde.
states that the probability of A plus the
Yeah.
to be 0, but that's hard to equal.
Yeah. Okay. Events that are mutually exclusive cannot exist at the same time. Okay, I know what that means. Mutually exclusive, blah 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 blah. It's not loading. Oh no.
You can visualize by looking at the diagram in the center, where the 4 jacks fill some of the sample.
I was trying to read all the messages in that group. You could probably pause the VOD if you ever remember and you can read what we said, or I'll just show you right now. It's not really that serious. It's just a stupid. We're talking about. Never mind. Don't worry about it.
This leads us to our first set of probability rules, the addition rules.
Okay. So we have the. Okay, whoa. Calm down. The addition rules. Mutually exclusive. We have P. Sorry, this doesn't say P. P-A. I'm going to underline or, because whenever you see or, it means you're going to add them. I think that's what it means. A or B equals probability of A plus probability of B. Simple. Okay. And then...
52, giving us a probability of 0.
Hurry up. I don't know what's not loading all of a sudden.
Equals 26.
Oh my god, yes, I know how to add. Thank you.
Is equal to the
Alright. Not mutually exclusive. Then it's going to be P, A, or B equals P, A plus P, peanut butter minus the probability, probability of A and B. Which means you're going to multiply those when it says and. I love how I'm saying you, as if anyone's gonna... Okay. Ow, my freaking eye is so itchy. Okay. Probably B given A, blah, 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 blah. Okay, conditional probability. Whoa! Refers to when an event is given. Probability of B given A. I hate doing these because I always get these confused with normal multiplication, but it's fine. Or actually, not multiple. I just had a stroke. I always get this confused with this one.
If event A is club.
Oh my god, yeah, okay, I know. Yeah. Load faster. Alright. We have multiplication rules. I learned recently that people don't know their times tables. That people didn't memorize these when they were a kid. This was completely mandatory in like 3rd grade for me, and then I also did like extra tutoring just so I can memorize this, which was stupid because I didn't need the tutoring, but it's fine. Eyes twitching. Doesn't sound good. Anyway, yeah, I learned that people don't know these. For me, like, I kind of get stuck in 12 sometimes. Sometimes. But generally, I know all of these. I just can't believe people don't know these. At least know 1 to 10. 11 isn't that... I mean, 11 and 12 aren't that big a deal, but at least know 1 to 10. Or at least, you know... 12. Oh! The heck, man! 49. This is 24. 6, 9, 54. 2, 5, 10. 60. 36. I have to, like, process it for a second on my keyboard. 40 also. Stupid frickin' animals, I can't. One time... See, this is where I get all tripped up. God. 96, bro. I don't know. I'm really bad at the 12s, to be honest. Embarrassingly enough, I'm really bad at the 12s. I just can't. Oh! 30. Cannot do math in your head? It's a really useful skill to have, as horrible as it is, because I hate it too. This is really hard to do while talking. It's really helpful. Especially, like, because I get really bad at social anxiety when I'm at restaurants and when I have to, like, pay for things. So, well, this is 72, but my fingers don't work. So stuff, if I'm, like, calculating, like, tips and stuff, or, like, oh my god, kill me. 70s, freaking 77, 80s, 82, 83. I don't know, it's 80 something. I'm bad at the 12s. When I have to, like, calculate a tip or something, like, I just get all, wow, brain stopped working. I get all fuzzed up because I just don't like doing that in front of people. So, memorizing your math kind of helps with that. But that's just for me. I know. I wouldn't say it's completely important for, like, normal living, but it's a nice skill to have in general, especially for times tables. Again, I can't believe people haven't, like, memorized these. Again, at least up to 10. That's, like, the most important ones. But everything else can go. When is this gonna end? Oh. This is 60. 411, 44, 88, 10, 5. Don't give me ones. Oh my god. 80, 88, 96. There we go. 0. The other one with the 12, like I just got really flubbed up on. But usually what I do is like times it by 10, then just add from there. 4. 10-y. 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 This is 56. 6. Guys, I'm so good at math. Wow. 55. City. Then we got 64. We got, oh my god, 90, 90, 99, 100, 100, 101. The timer is really stressing me out. Oh my god. Oh, we're not done yet? Oh my god. Hooray! I got an A. What's 60 divided by 65? Even I don't know that. 92? Hey, I got an A, guys. I'm so happy. Ooh. We have a multiplication duck. Whatever that means. Oh my god, there's music. I can't see it. Can I make this full screen or something? Complete the equation correctly and reach the exit door before time runs out. What? WASD. Okay, I can do that. Come on! Jump! It's 3 times 2. Oh, this is cute. I love this. 4 times 3 is 12. And 5 times 4. Oh my god! 5 times 4 is 20. Oh my god, I have to jump up again! Now I gotta make it. Hurry up. The music goes hard, not gonna lie. We have 7 times 5. I didn't even see the spikes over there. Jesus. 7 times 5 and 5 times 6. Where's the key? Are you serious? It's right there? I could have died from that, you know? Oh my god. Okay. We got 4 times 2 is 8, 9 times 3, 8 times 3, and then 5. So what was it? What did I just say? 4, 9, 8, 5? 4. Oh, it was right here. 9. Oof. Ah! Okay. 8, 5. How in God's name am I gonna get over there? In 5 seconds? Ah! This is freaking hard. Oh my god. This timer is really stressing me out. Alright, we have 3, 9, and what is that? 9. 3, 9, 9. Wait, what? 3, 6, 9, sorry. 3, 6. Oh my god. 9. Why? Why do you have to be so far? You're doing this on purpose. Woo! I am a speedrunner. This is, brain not working. Brain not working. 4. Sorry. 4. 4, 10, 6, 8. Oh my god, what's happening? 4, 2, 6, 8. Sorry. 4, 10. What am I doing? Come on. Hurry up. Hurry up. Hurry up. Hurry up. 2, 6. No. 7. Sorry. 2, 7, 1. 2, 7, 1, 2. 2. Ah! Oh no. Oh no, I screwed up. Yep, kill me. 2, 7, 1, 2. How am I gonna do this in 15 seconds? 2. Ah! Okay. 2, 7. Hurry up! Hurry up! Hurry up! Hurry up! Hurry up! Hurry up! Why? Why? Okay. Okay, 5, 8, 16, 30. 5, 8, 5, 8, 16, 30. 5, 8, 6. Oh my god! This is really fun, I'm not gonna lie. 5, 8, 16, 30. Frick, dude! Get out of my way! 5, 8, 16. 16, 30. Alright, hurry up. This is so fun, I'm not even gonna lie. Okay, we have 64, 56, 28, and 32. It's this one. Oh, this is 9. Sorry, 36. I thought this said 8. Oh my god, kill me. Oh, why? Why me? Oh my god, how am I didn't even see that, to be honest. Nope, that's not gonna make it. Oh my god, just kill me now. Dude, get out of my way! Oh my god, what is this? Okay, what the heck? Oh, my brain literally stopped functioning. Okay, 6, 8, and 16. Jesus Christ. Okay. Oh my god. Oh! 6, 8, 16. 6, 8, 16. 6. Oh, why? How am I supposed to get up there? This game is cruel. 6, 8, 16. Where is it? Oh my god, why? Why? The music's really nice though, I'm not even gonna lie. 6, 8, 16. Okay, we're good. Okay. Oh my god. What order does this go? 3, 3, 10, 133? 3, 10, 133? 3, 10. Oh my god, I forgot that those were even there. 3, 10, 133. 3, 10, 133. Why is it over there? Why do you make my life hard? I just don't have the skill for this, to be honest. That could be what? 5, 11, 3? Okay, I love that. Please move. Actually, I think I can make it. 5, 11, 3. Are you freaking serious with me right now? What in the world? 2, 2, 2, 2, 11, 9, 11. 2, 2, 11, 9, 11. 9, 11? 2, 2, 11, 9. Get me out of here! 2, 2, 11. Oh my god, kill me. 2, 2, 11. Oh my god! 2, 2, 11. I just want to just... Great. I like how it instantly kills me if I get it wrong. 2, 2, 9. Chill. Chill out here. 9. 11. Please don't stop there. Are you freaking serious with me right now? Okay, it's gonna end up over there. I just want to see where the key would be. 2, 2, 11, 9, 11. Quick, 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 quick. Speed run. Speed run, please. Okay, we're good. Okay. 10, 5, 7. What? Five. This is getting too complicated for me now. We need to do... Oh, it's saying we need to do 5, 7, 10. So... 5... 7, 10. Okay. This is friggin' hard now. This is not fun anymore. 72. 72, 11, 7. Okay, we need to do 7. Wait, what did I say? I said 72, 11, 9, right? What did I say? No, I said 72, 11, 9. Wait. 72, 11, 7. 72, 11, 7. 72, 11, 7. So if we do 7... How do we get over there without touching that? Yeah, we'll do 7... 7, 72... Okay, we'll do that. 7. Oh, great. Awesome. Okay, cool. Yeah. Oh my god. How am I supposed to do this in 15 freaking seconds. Oh my god. I waste like 2 seconds just jumping up here in the first place. Oh my god. Oh my god, I missed it. Are you freaking... I love my life. How come I don't jump on time? Oh my god. This could make me go insane. How the heck am I supposed to get up? Oh, I see. I see. Oh my god. You want me to go up here? Really? Oh my god, I almost hit the ceiling. Okay. We have 10, 1, 10, 1, 2, 1, 10, 1, 2, 1, 10, 10, 1, 2, 1, 12, and 50. Oh, sorry, 2, 2. So we can do... We need 1 to 1 to go first. Okay. 1, 2, 1. 12. Are you freaking serious with me? $12. Give me that. That was such a trap, okay. Oh my god, kill me. I don't like multiplication duck anymore. I don't like this game anymore. Actually, here, let me try it. Let me just do it one more time. Oh my god. Hurry up. I was literally walking.
Anyway,
biostatistics.
is fairly simple and allows us to calculate probabilities fairly
That was
easily
so
when events A and B are
painful.
independent. However, events A and B are not always independent. When this happens, we have to use conditional probabilities, and we would usually use a probability tree diagram.
I didn't even write down the rules. Okay. So it's usually P A and B equals P A times P B given A, right? That's what it means? Yeah. Then when events are independent, P A and B equals P... Nope, I didn't say P. P A times P B. When events are not independent, I usually use a probability tree diagram to calculate probabilities. To calculate, I'm too lazy to type out probabilities.
Not independent.
Yeah, I know how to use this. Yeah.
Independent, then the probability B.
Blah 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 blah. Okay, we can determine if events can be independent. Okay. Events are determined as independent by separately measuring them, then comparing P, A, and B, P, A, and peanut butter. Okay, what the heck is Bayes' theorem? Bayes' theorem just gonna screenshot that. I don't feel like writing that out. There you go.
With a little algebra. First,
Oops. Yeah. Alright, Bayes' theorem is used to solve for conditional probabilities. What is the probability that oh, I remember this. Okay, never mind. I'm good. I remember this. La 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 la. Da 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 da. We just got all that. Okay, cool. Alright, besties. Is binomial... What? Is this what I just got? Normal
The normal distribution.
Okay, whoa. Okay, but okay, no. I see. Oh wait, this wasn't actually the 18th. It was supposed to be... What was Tuesday of last week? The 7th. Right? Right? God, this is annoying. Yes, it was the 7th. And then the other lecture that we had was on the 9th. Or it would have been on the 9th if I had gone to it. Okay. Video lectures. Intro to binomial probability. I can never freaking type that word. Okay, this I have never... Actually, I do remember learning about this in high school, but I don't know. I've kind of lost... I've lost all my memory of it. I'm yawning.
This introduction to binomial probability.
I'm yawning because I'm freaking bored of this.
The binomial probability equation comes from, the mathematical assumptions, and what this can be used for, which is more than just the probabilities of flipping coins, although that will be our first example.
Let's think
about the basic scenario for binomial probability. Let's do a series of n trials where we are looking at the outcome of our events.
Yeah.
Is n number of tails.
Okay.
3 times. Big example.
Okay.
The 2 outcomes were heads or tails. The coin never landed on its edge or disappeared. Second, there are n trials. When we do binomial probability calculations, we need to know exactly how many trials are being performed. Third, the probability of success of each trial is constant as we do the trials. This will allow us to use one probability value for all the different trials. Fourth, all the trials are independent. This means the results of early trials have no influence on the results of later trials. This also allows us to use the same probability value for all the different trials. The third assumption, the probability of success being constant, technically means that we would always be doing sampling with replacement in any scenario measuring individuals in a population. If we did sampling without replacement, the probability of success would change, so our math wouldn't work. However, if our population is large enough, even if we're doing sampling without replacement, things should be fine. The
number
fourth
folk
assumption,
trials.
the trials being independent, will allow us to use the special addition rule. The overall probability of x successes would be the probability of one combination of successes and failures that gives x successes, or a second combination of successes and failures that gives x successes, or a third combination, etc. Like in the coin flipping example we looked at, there were 20 different combinations and we had to consider them all. If all the trials are independent, then we can calculate the probability of combination 1 or combination 2 or combination 3, etc. by calculating the probability
Addiction
of
rule?
1 plus the probability of
Sorry,
combination 2 plus
addition.
the probability of combination 3, etc.
Yeah.
Some successes and failures that give x successes. If the probability of success is constant, all the combinations are equally likely. We could therefore calculate our choice of one combination and then multiply that probability.
Oh my god, that is so confusing.
And x are successes, then the number of different combinations will be given by the equation to the right. We read this equation as n choose x, and it is equal to n factorial divided by x factorial times n minus x factorial. In case you don't remember, the exclamation point represents a factorial, so n exclamation point is n factorial. Factorials are calculated by taking the number...
Today I just really can't type, it feels like.
...integer less than it down to the number 1. For example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. Note also that 0 factorial is defined as being equal to 1. So thinking about 3 successes in 6 trials, this would be 6
Oh
choose
my
3,
god.
which is 6 factorial over 3 factorial times 6 minus 3 factorial. Writing out what this represents gives us 6 times 5 times 4 times 3 times 2 times 1 in the numerator, and 3 times 2 times 1 multiplied by 3 times 2 times 1 in the denominator. A nice feature of fractions with factorials is that often lots of cancellation occurs. For example, the 3 times 2 times 1 cancels on the top and the bottom, and the 3 times 2 times 1 in the denominator is equal to 6, which cancels with the 6 in the
Okay.
numerator. The whole thing reduces nicely down to 5 times 4 is
Ooh. Shortcut.
equal to 20.
Love it.
2 quick things before
Okay, I don't love this.
calculations. First, n choose x is also written using other nomenclature. All those terms there are also used in different places.
How do you
to
even
represent
type
a small
this?
fraction of factorials. When you're reading about binomial probabilities, you'll have to take a little bit of time to figure out which shorthand.
God, that is so freaking, that's so much. Okay. Let's put that bad boy up there. I really would hate to have to memorize all that, but okay, it's fine.
They're using. About 20 comes from
What?
for 3.
I have seen that before. I don't remember what this is called, but I do remember that. Calculate our choice of one common. Oh my god, kill me. Calculating binomial probability. I'm just gonna totally give up on trying to spell probability. Probability of one combo of x successes equals p success. Wow, I don't want to write all of that out. We're just gonna screenshot it. We're just gonna screenshot it, and okay. I thought I had a YouTube screenshot extension. Okay, that scared me actually. Oh my god. Where even was I? I was somewhere over here. Nope, somewhere over here. Hi, Maxie. Hi, Maxie. He's so cute. Okay, bye. Yeah, I thought I had this. What in the world? Give me that. We stopped at 7:30.
Welcome to this introduction to
7:30, 7:30. Alright, give me that. Yeah. Put that down here. I love Notion. It is so freaking... What's it called? So convenient. Okay, this is him just doing it, for example. Okay. Binomial probability distribution.
From 0 up to the maximum. On the y-axis, we have the probability of observing each number of successes when we...
I always have to like miss at least like one letter while spelling this word.
Probability values is called a probability distribution. So this is the binomial probability distribution for 6 trials with a probability of...
What did he say before that?
We have the probability of observing each number of successes when we do all of our trials. A distribution of probability values is called a probability distribution.
Okay,
so
great.
This is the binomial probability distribution for 6 trials with success. The probability of 0.5.
Okay, is it saying... Are we getting to p-values now, or is this... Okay, you're saying probability of blah blah blah. Probability of success. Okay. Take many samples, blah blah blah. Holy moly. Oh, if you take many samples of size and from a population that exhibits a binomial distribution with success. Oh my god, okay, we're just gonna Google this. Probability distribution. Common. Is it common? Probability. Look, see, I always miss the B. Probability distribution representing the probability of obtaining one of two outcomes. One of two outcomes. Okay. Success. Success versus failure. Okay. Makes sense. This does not match that, but that's fine.
Sample of 2, the 4, the
Mm-hmm. What is S? Success? Probability of success 0.2. Oh my god, where'd you get that equation from? Maybe we stop skipping through literally everything. Let's take this. A lot of this is equations, so I can't really write notes about them. I hate those, by the way. When I can't just write my own notes about it and I have to like actually like screenshot whatever they're giving me. Like, oh my god. Oh, didn't mean to like it. What is S? What does S mean? Did he say what S means? Why is it zoomed in now?
0. This probability of success is S. This S of 0.5. Probability
What?
values is called a probability distribution. Success. The probability distribution. We've looked at an example.
Okay, what is
Simple
S?
binomial probability distribution. Let's think about the mathematical properties of the binomial probability distribution in general. In real-world applications of binomial distribution looks like for those samples. If we take many samples of size n from a population that exhibits the binomial distribution with success probability p, the expected values for the set of samples will be as shown. The mean number of successes in those samples will be the number of trials times the probability of success.
Okay.
The variance of the number
Variance,
of successes
probably.
in different samples will be equal to the number of trials times the probability of success times the probability of failure.
Okay.
For example, if we have 100 trials with a probability of success of 0.2 and we took a bunch of samples, the mean number of successes in those samples will be 20. The variance of the number of successes in those samples will be 16, which would give us a standard deviation of 4 and a coefficient of variation of 20%. If we have 100 trials with the probability of success 0.5...
So are these like normal values, I'm guessing? I think that's it. Measure the distribution of samples for which we know compared to binomial matches problems. Okay. Then 34 is in the region expected if the region is possible as well.
Plus or minus 1 must be binomial.
Okay.
To the number of successes.
I'm just gonna take an L on that one. And then just keep on going. Also, that's definitely not week 4 anymore. Oh, now it's week 5. Alright, so now we're in week 5. And it would have been, this lecture would have been on the 14th, Valentine's Day. Except, what did I do for Valentine's Day? I went to get sushi with my friends. And it was freaking yummy. Poisson probability distribution. I almost just want to read the PDFs instead of listening to it because it doesn't really explain it, but you know what? It's fine. Just watch them. Boop-a-doo. Boop-a-doo. Second to last digit of my student ID. I'm pretty sure it's C. It's not. It's 3. We're almost done, guys. We're almost done with class. Oh my god. I'm just gonna go to bed after this, actually. Okay, we're gonna close that.
Welcome to this introduction to Poisson probability.
Oh, Poisson, sorry.
Poisson. Mathematical functions and a few examples of applications.
Poisson.
First, though, this distribution is named after Simeon Denis Poisson.
Poisson.
It should be confused with the English word poison or the French word poisson, which
Poisson.
is fish. The Poisson distribution comes from the binomial.
The way he says it.
A special case of the binomial under certain circumstances. If you're familiar
Okay,
with
we're
the
screenshotting
binomial,
that.
you'll remember that it describes the probability of seeing x successes in n trials when the success
Poisson!
times p
Sorry.
is given by the equation p of x equals n choose x times the probability of success to the x power times the
Okay, yeah, I get it.
trials or probability of each.
Unlike the binomial, which requires a set of numbers of trial. Okay. The Poisson! Probability does not require a set of trials. It can be used for the probability of seeing X events in an area or over a set time period when we know the mean. Potential number can be unknowable. Binomial can't be used. Or maybe it can be used, but apparently it's not appropriate. Next! Poisson! If we know the number, we know the average number of snails per square meter is 3, what are the odds of seeing none? If I know there's an average of 5 deaths in a retirement home per month, what's the chances of seeing 10? Okay. Okay, like in a physical area. Okay, got it. Oh my god, what in the world is limb? Assumptions? I'll underline that. Events occur randomly with respect to one another. Events are relatively rare. Probability of occurrence doesn't change over time. What in the world? What in the world? Poisson!
Randomly, this assumption. Second, the events are relatively rare. This is what allows us to replace the binomial equation with the Poisson equation. Third, the probability of occurrence doesn't change over time. This assumption comes directly from the binomial distribution's assumption of constant probability.
Ow, just cracked my toes.
One way to think about the Poisson distribution is as the limit of the binomial distribution as the probability of each event goes to 0 and the number of trials goes to infinity. The Poisson distribution is as the limit of the binomial distribution as the probability of each event goes to 0 and the number of trials goes to infinity. The Poisson distribution has an incredibly useful property whereby the mean of the distribution is mathematically equal to its variance. The entire distribution can therefore be specified with one value. This is useful because this relationship can be used to test hypotheses about whether a distribution we observe is due to Poisson, that is random, processes or not. If it is, then the mean should be equal to the variance. This is usually tested using the coefficient of dispersion, represented by the equation to the right, where the coefficient of dispersion is equal to the variance divided by the mean, and we're usually interested in whether it's equal to 1 or not. Let's look in more detail at the coefficient of dispersion and what it can tell us.
Coefficient
It's equal to the variance divided by the mean
of dispersion, aka cooldown.
The top figure
Oh
shows
my
Poisson
god.
distribution
Oh, speaking of cooldowns,
and dispersion equal to
I've been playing Overwatch, obviously, like I mentioned earlier, and holy, hi Matilda, and I've been meaning to try out new tanks because the only tank I know how to play, because she's super simple, is D.Va. Because literally all you have to do is just shoot, and then when her ult comes, you just boom. I know how to play D.Va, and I can maybe play Sigma if I'm really feeling it. But I decided I need to learn more tanks that aren't D.Va, because sometimes I'm not in the mood to play Sigma if I need to switch off a D.Va. And so I decided, at the recommendation of, I believe it was Dare who told me that. It might have been Dare or Naveed, I can't remember. But one of them, they're like, oh, you should play Orisa. And at first, I actually don't even like Orisa. Like, at first when I started playing Overwatch, I hated Orisa because she's so annoying to counter. And I don't know, she just looked pretty complex to learn. But I tried playing her recently, and I love playing her. She's really fun. I'm pretty awful at her because I just started, to be fair. But she's really fun, and I like her a lot. Anyway, Poisson. CD equals what? CD's nuts. Probably Poisson. Random. If CD is less than 1, distribution is under dispersed and uniform. CD is over 1. The distribution is over dispersed and clumped. Under dispersed and uniform, that means you're all bop, and then clumped is like, oh my god. Anyway.
Like the dispersed or goes in the square. And the random
Whoa, okay, that's different. Over dispersed. Let me screenshot that bad boy. Drag you over here. Hi. Can I not put it under the image? Whoa, they're fighting. I don't know if you heard that, but they're fighting. She's like, wow. Consecutive. Oh my god, there's just so much math. Consecutive Poisson probabilities are related to each other. Oh my god, I'm not learning all that. Sorry, I just can't right now. It's almost 12 a.m. If we know what a process is random and we have a mean, then we can predict probabilities in proportion. A lot of application. Don't really care about application. Okay, next.
The normal distribution is the most important probability distribution in statistics.
This is the one I actually know decently.
Where it comes from, what it's used for, and why it's so important. The normal distribution is the most common probability distribution in statistics. It's based on the binomial distribution, which is the most fundamental probability distribution. In fact, we can think of the normal distribution as the limit of the binomial distribution as the number of trials becomes large and the probability of success of each trial is 0.5. If you don't remember much about the binomial distribution, this channel and playlist have a video all about the binomial distribution you can take a look at. The figure here illustrates the binomial distribution for 10 trials and the probability of success of 0.5. You can see that as we increase the number of trials, the shape of the binomial distribution changes slightly. And as we increase the number of trials even more, the shape of the distribution changes even more. And here we can see how the shape of the binomial distribution with lots of trials on the left can be represented by a smooth curve as shown on the right. Even though these two figures look different, one is a histogram and the other is a curved line, they are representing the same thing, a distribution of probability values corresponding to values on the x-axis.
Okay.
As we begin to think about this normal probability distribution, it's important to remember exactly what's being represented. On the left, the histogram is showing a particular probability corresponding to each number of observations on the x-axis. If we wanted to know the probability of some particular range or group of observations, seeing somewhere between 25 and 35 observations for example, we would add up those individual probabilities to create a sum of those probabilities. We would essentially be calculating the sum of the heights of a set of those individual bars. On the right, the curve is showing the probability corresponding to each location along the x-axis. If we wanted to know the probability of some particular range on the x-axis, the proportion of the total probability corresponding to between 25 and 35 for example, we would calculate the area underneath that curve. Note that since this is a probability distribution, we know that the total area underneath the curve is equal to 1. The value we get for the area of a region therefore represents a proportion of the overall set of probabilities. Looking at our histogram situation in more detail, we would calculate the overall probability as the sum of all those individual.
So freaking confused right now. There's so much going on.
Looking at our probability curve situation in more
Ow,
detail,
I just disconnected my charge. Okay.
As the integral
Even better.
underneath the curve along the range of values
Put that
on
back.
the x-axis we're interested in.
I hope it didn't
To
screw up
perform these
anything.
integrals or
Oh, it did.
calculate areas, we would need the equation for that curve
Oh,
that
just for a little
represents
bit.
those probabilities. The top equation to the right is the general equation for a normal distribution curve.
Okay.
f of x equals 1 over sigma times the square root of 2 pi times e to the
Whoa, my neck
exponent
cracked. Did anyone hear that?
half, and then in parentheses,
That's
x
loud.
minus mu divided by sigma squared.
Uh-huh.
The bottom equation to the right is the equation we would get for a normal distribution corresponding to the binomial with 50 trials and a probability of success of 0.5. The mean would be 25, the variance would be 12.5, and the standard deviation would be 5.
Ba ba ba.
The normal distribution. The equation
Wait,
larger
what?
than the height of the normal distribution is lower. The equation for the normal distribution can be simplified if the mean is equal to 0 and the variance and standard deviations are both equal to 1. Under these conditions, area centered around the mean equal to 1. If the standard deviation is larger, then the height of the normal distribution is lower. The equation for the normal distribution can be simplified if the mean is equal to 0
Distribution.
and the variance and standard deviations are both equal to 1. Under these conditions,
That is the same. Oh, right, this one.
The standard normal distribution has the same shape as the normal distribution, but you can see that the equation is much simpler. F of x equals 1 over the square root of 2 pi.
Wait, what did he say about the other ones?
The distribution of the normal distribution is lower. The equation for the normal distribution can be simplified if the mean is equal to 0 and the variance and standard deviations are both equal to 1. Under these conditions, we get a normal distribution called the standard normal distribution. The standard normal distribution has the same shape as the normal distribution, but you can see that the equation is much simpler.
Okay,
It
yeah.
can be transformed into
Any set of values with normal distribution of mean and standard deviation can be transformed into the standard by, okay. Why can't I tab this? Okay, whatever. Above equation can be transformed standard, which is that. Blah blah blah.
a new set of portion above.
Allows us to calculate okay. Calculates probabilities for values in regions defined by a mean and standard deviation. Yeah.
Below the mean, we're in a 7.
For a data set poopy. Did Ryan ever reply if he's gonna play? Nope, he didn't. For a data set with mean and standard deviation has so what equation are we using? We're using what? I thought we were okay. What? What in tarnation? Ooh, my mom was visiting earlier and I told her that my bike tire got flat because I was using it, and then some guy came up to me and was like, your tire's flat, and I was like, oh, I didn't even notice. Anyway, and she just texted me saying that she's gonna send me a new tube to pump air into my wheel. Not the same thing. The same thing, right?
Of z equals negative 0.2 and z equals positive 0.6. So to recap, we have an equation for a normal distribution with a mean of mu and standard deviation of sigma, and we can calculate probabilities by calculating integrals for the area under the curve between two values. If we transform these values...
What?
Just like I'm sorry for how loud that was. I thought I had to yell it because I'm like watching this guy review all the SpongeBob video games and it's pretty loud. I'm pretty sure you're gonna hear it here, but yeah, sorry for yelling, boss.
I played those voice clips on full speaker while I'm streaming, like right now. They're very loud. Thanks for that. Just like Gangnam Style.
Just like Gangnam Style. Just like Gangnam Style.
You guys can hear that, right? I'm not just laughing to myself. You can barely hear it. Wait, hold on.
Just like Gangnam Style.
I love it. It's great. Just like Gangnam Style. What the hell, man? I posted on my Instagram story that I went to this Korean barbecue place called Gangnam. Replies. Just like Gangnam Style. Okay, anyway. That was so quiet. Why was it so quiet all of a sudden? That was weird. Uh-oh, now OBS won't open.
Into z values.
Just like
The procedure
Gangnam
is
Style.
equivalent to finding the area under the standard normal distribution curve between the z values corresponding to the original values. So how do we calculate the area under the standard normal distribution curve? Unfortunately, it turns out that this integral cannot be solved.
Oh, great.
Not that it's hard.
Just like Gangnam Style.
Area under the curve to the left of a particular z value. We can then calculate areas for ranges by looking at values in the tables and subtracting. Of course, if you're doing this using a computer, it has all those tables. We would go to our table of
my
z
God.
values and locate the area value in the table that corresponds to the z-score of 1 point showing you.
What in God's name is an integral? I feel like I was supposed to take calculus before I took this class, and obviously I did not, because as you could tell, I have no idea what that means. So, yeah. I'm gonna totally pass this class. Oh yeah. I think this is all application. Okay, I'm probably gonna need to come to office hours or something, because I have no idea what any of this means. And of course, our homework is super freaking long. Just like Gangnam Style. Alright, I did. Guys, we finished. After almost an hour and a half, we finished one thing. Let's go. Just like Gangnam Style. Yeah. Uh-huh. Busan! Maybe I can do it. What if I just believed in myself? Maybe I could do it. One moment. I have some scratch paper right next to me, and a dream. That's what I have right now. So we're gonna pull this up. Okay. So mean is this U-looking thing. I know that for sure. For a sport of NFL football during the 2021 season, there were 1,423 touchdowns scored during the regular season. There are 272 games played during the season. You'll use the Poisson distribution to estimate probabilities of games with a certain number of touchdowns. What is the mean number of touchdowns, TD, okay, scored in each game during the season? Round the answer to the nearest. Oh my god. Okay. Okay, there were, so N, well, we know N. N is, wait. Wait, what? There, I don't know, bro. Complete the, oh my god. Yeah, I don't want to do that right now. We're gonna skip that and do something else. I kind of want to do chemistry. I feel like doing chemistry, but to do this, I need to log in. I don't want you guys to see I don't even know if it's gonna show my last name, but just in case. You know what? Play some music while we wait. One moment. It does show my last name. Great. Okay, hold on. Bum 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 bum. We're gonna do. Okay, it very much does show my last name, so we can't do that right now. All right, what else can we do? While we. What's on my list? Oh, we did a lab assignment. Okay, we can do that. Wait, let's not do that late. I have to just check if I can see. Hold on. R Studio. What's it called? Posit. Like deposit. Dum bum ba dum ba dum. I put my name as Hatsune Miku in this, and I was told to change my name to my actual name. That's makes me sad. What do you mean I can't be Hatsune Miku? It shows my last name too. Great. I can hide that though. Dum, bum, dum, bum, ba, dum, bum. Okay. Binomial Pause. Binomial assignment R markdown. Okay, we're gonna make a new folder called homework, and then put those two in. Gimme, gimme, gimme. Gimme, gimme more, gimme more, gimme, gimme more. Give me these. Alright, besties. I think... Yes! Okay, won't show my name. Alright, come back, besties. This is very loud. Oh, wait, it does show my name. Okay, hold on. Hold on. Hold on. How do I rename this? This is how. Select a single flyer to rename. Why can't I just... Oh, okay. One. Okay. Da 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 da. Error saving. Save, yeah. Shut up! Just let me close it at least. Okay, yes. Don't save. It's fine. Okay, hold on. Pause. Everybody pause. Or actually... I can keep this. Keep this. Put this. Put this. Upload. Blah blah blah. Put that baby in. Put the- oh my god, nope. Put this one in. And then give me this. And then... Load in required packages. There's no packages, but... Oh my god. Fill out your name. File choose. Give me this. Give me the CSV. Okay. Okay, I think we're good now. Now I just need to close that. Alright, besties. Okay, now we're good, I think. Let me just hide. Okay, we're good now. We're good. I think we're good. Okay. Alright. Oh god. I don't think it loaded in correctly. Okay, we're not doing this right now. We're gonna do something else. I'm so scuffed. Most of those things I can't do on screen. Okay, so I can't do that yet. Homework? I don't know what the homework is actually. Let's go check. Let's go check, except it's gonna put my name on it, so I can't, I can't show it again. Hold on. If none of these work, we'll just jump straight into doing the fun stuff. Okay, homework. Chapter... Yes. Okay. In the world? Did I already finish my... Did I do this already? I did! Oh my god, I'm an idiot. Wow, I am one heck of an idiot. I submitted my physics homework. But I remember when I was doing it, I was BSing it. Because I knew that I was gonna... I didn't know anything on it. But I accidentally pressed submit. So that's fun. Okay. Good to know. So, technically I did my homework. Did I do it well? No, I probably did not. I actually most definitely did not. Oh, I meant to do this one. God, I'm really stupid, aren't I? Alright, you did that. Okay, great. Hold on. Okay. For 20... Why did I do it? God, I'm so stupid. Dag nabbit, bro. La la la. Oh, you know what we can do? Here's what we can do. We can do this stupid worksheet that I really don't want to do. Hold on. Again, I can't show you guys anything. I know you can't see anything. Don't be scared. Everybody calm down. I know you can't see anything right now, but calm down. Everybody just calm down. We close this. I never did that. Open this. Sheet 5. That's it. Alright. Give me this. Oh my god. Okay. Periodic table, blah 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 blah. Ooh, what's this? That was a lot of stuff. Alright. We will... Actually, let's do that too. Blank periodic... Oh my god, don't tell me we have to memorize the... Oh, yes, we do. We have to memorize the entire periodic table. Okay, let's go do that then. We can do that today. Periodic table. Memorization game. We'll do it. Why not? Fun brain? Ooh, GeoGuessr. I'll do GeoGuessr. Sure. Oh my god. Okay, we can do this. This is something we could do. No name on anything, no name on everything, everything's good. No name on everything. Okay. Put this bad boy in. Oh yeah, oh yeah. Put this here. Sorry, I know. It's freaking, there's nothing on screen. Hold on. Hold on. Calm down. Everybody chill out. Okay, we're ready. Wait, hold on. No, we're not. Okay, now we're ready. Alright, besties. It's time to do what I've never wanted to do in my entire life. This is so nerdy. Literally the most nerd thing I've ever done in my life. We're gonna do this for like 10 minutes. And then we will do some... I don't know, we'll do something together. Okay. I don't need to have the mic resting on the floor for this. I can just put it next to my face. Alright. So first we're going to memorize just the names of everything because I have no idea what most of these mean. Reduce together. This is the most nerdiest thing I've ever done in my life. That's okay. Click on xenon. I'm gonna assume that that's xenon. Rutherfordium. This one. Sulfur. It's probably S. Germanium. This one. Uranium. Is it U? Okay, it is. Indium. See, most of these are self-explanatory just by the letters alone, but then I think she wants us to, like, actually memorize, like, where everything is, which is stupid, by the way, but whatever. Argon. This one. Caesium. Or caesium, if you're doing Latin pronunciation. Caesium. Uh-oh. This one? Oh, wow, holy. Promethium. Oh my god, kill me. PM? Oh my god, I've been really lucky. Copper. That feels like a trick. Yeah, I knew it was. CR? No. Cl's chlorine. Copper? That's cadmium. What in God's name? Oh my god, that scared the heck out of me. Me too. What in the world is copper? Calcium. Phosphate. Phosphorus, sorry. Copper? Ru. Why does it Cu? Bro, see you later for real. Magnesium. Calcium. Radium. Silicon. Molybdenum. Mercury. It's Hg. Where are you? This always tripped me up forever because there's the way you measure blood pressure, I believe, is by millimeters of mercury or something like that. I don't know. You measure some kind of bodily thing with mmHg, millimeters of mercury. And I always wondered, why is it called millimeters of mercury? Milliliters, I don't know. Millimeters, whatever. A mercury. And there's Hg, and I found out that Hg is mercury.
Yes, queen.
This is perfectly timed. Yas, queen. Millimeters of mercury. Yas. Hafnium. Probably that one. Niobium. Neo. No? Nobellum. NB. Ytterbium. That's yttrium, of course. I would have known. Ytterbium. Who is freaking naming these? Arsenic. Yes. Phosphorus. Oxygen. Hassium. Hassium. Where are you? What do these mean? Hassium. Oh, these are indicating these ones. My bad. Duh. Hassium. Iridium. Iodine. Sorry. Iridium. Ferminum. That's iron. I don't know why I confidently clicked that. I knew that was iron. Fermium. This one? Okay, cool. Helium. H-E. Sorry. W. I'm so confident and then I just completely forget. Dubnium. I get dubsnium. Nobelium is a U. Silver is a G. Lithium is Li. Bismuth. I didn't know bismuth was an element. I thought that's a depressium. That's really funny. Dysprosium. Oh my god, kill me now. This one? Darmstadium. Who in the world? Dysporium. No one knows these. You know what I mean? At least, the more important ones are these first 4 rows. Pretty important to know most of these. Everything else, you can live without them. Live without knowing what they are. Not live without. Actinium. Einstein, not Einsteinium. Who in the world? Europium. Oh my god, these names. Neptunium, that's a cool one. Fluorine. F. Krypton. I didn't know that was real, to be honest. Krypton. Like kryptonite. Oh my god, where is KR? There you go. Chromium. This one? Cadmium. See these nuts. Platinum. Platinum can't be freaking starting with P. I bet something weird. This one. Okay, I lied. Samarium. Suck on these nuts. Samarium. Oh my god, this one. Radon. Can we stop discovering things? Because this is really taking a toll on my memory. Radon? Maybe this one? Tellurium. We have TM, but we also have, oh, never mind. TE. This one. Lanthanum. That one. Osmium. like osmosis. Berkelium. Selenium. Se. Thulium. That's a cool sounding one. Thulium. This is so nerdy. Oh, my bad. Thorium. Thulium, curium. I feel like that was named after Marie Curie. Sodium is Na. Plutonium is... What the heck is plutonium? It's PD. Do you have a PL? PL? Any PLs in chat? PU? PU. Neonium. Nihonium. U? Nickel. Nihonium. This one. Iodine. What in the world? Roentgenium. U. Of course. Mendelevium. I hate this so much. That's manganese. I think. Or is that something else? No. Mendelevium. U. Polonium. If I don't recognize it here, it's probably done here. Polonium. Po. Zinc Z. Gadolinium. U. Tantalum. U. Thallium. Tantalum. U. Beryllium. U. No, the barium. Beryllium. U. Bromine. Beryllium. U. Oh. Praseodymium. Oh my god, these names. Praseodymium. Oh my god. Of course it'd be PR. I don't know why I didn't look at that first. Chlorine. To boarding over this. I hate studying. Chlorine Cl. Moscovium. U. Aluminum. Oh, sorry. That's actually aluminium. Like, that's actually aluminium. I've always made fun of people who say British people saying aluminium. But they're right with that one. That's aluminium. Good night, going to sleep. Good night, Minkin. Thanks for stopping by. I guess you could say that this stream was boron. Thanks for watching. Tungsten. U. Did I say Tennessee? Tungsten. Oh my god, I've seen tungsten before. I don't know why I'm like suddenly losing it. I don't know. Oh no, where is it? Of course it's W. Carbon C. Oh my god, that scared me. Jesus. Thank you for clapping. Hello. Or actually goodbye. You're leaving, aren't you? Lawrencium. That always scares me. The sound alerts always scare me. The heck is Lawrencium? U. Jeez. Iron. That's gold. Iron. Potassium. Iron. Strontium. Strong. Bye-bye. 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 Neon. Shmee. Neon. Nitrogen. Neon. Okay, why aren't these easy now? Neon. Or I think I'm just blind. Cerium. There are no more C's. Hydrogen. Manganese. That's what I was saying earlier. Thorium, you're the one that I mentioned earlier. Thorium. Francium. The French have a have an element. Francium. Gold is AU. Borium. Probably that one. Livermore. Okay. California. Hey. No time to party. In the city. Oh, we have one. Californium and Americum. Americium. Americum. Thallium. U. Rhenium. Rhodium. Rhenium. Cobalt. Flavorium. Rubidium. 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 Rhodium. Scandium. Yttrium. Vanadium. Copernicum. 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 There are no more C's. We just have this one. Okay. Matnarium. Matnarium. Darmstadt. What are these names? Seaborgium? Tennessee. I don't know. Gallium. I know that said, what was it? Tennessinium, but I don't care anymore. Nickel. Nitrogen. Erbium. Protactium. Protactium. PA. Why would I choose PR? Like that. Barium. Potassium's K. Holmium. Zirconium. Ruthenium. Terbium. Terbium. Astatine. Astatine. Come here. Tectinium. Neodymium. Tin. Tin. Alright, I don't know. One of these. There you go. Lead. One of these. Antimony. Why don't you... Okay. Something. Palladium. Okay. Not terrible. I mean, it's pretty bad, but it's not bad. Okay. What's wet? Let's take this a little bit easier. We'll do this. Oh, good lord. Nitrogen. Nitrogen. Fluoride. Oh god, this is awful. Argon. Lithium. Aluminium. Oxygen. I did not say your name, Alexa. Chlorine. Boron. One of you. Okay. Silicon. Phosphorus. Sulfur. Sodium. Neon's here. Really? I thought it was just these two first. Oh yeah, neon. Hydrogen. Helium. Beryllium. Carbon. Magnesium. Okay. Again. I already forgot where everything is. Boron. Nope. Boron. Nope. Boron. Okay. Sodium. What have you... Argon. Okay, we're redoing this. This is embarrassing. Lithium. Oh my god, I just had that too. I can't remember. Where is it? Okay, argon. Hydrogen. Lithium. Nitrogen. Neon. No? No? Neon? Boron. No. Boron. No. No. Boron. Sulfur. Helium. Carbon. Sodium. Beryllium. Aluminium. Oxygen. I almost screwed that up. Still screwed it up anyway. Oh, I was right the first time. Magnesium. Phosphorus. Chlorine. Chlorine, fluorine. Okay. Okay, pause. I'm gonna do this at least once a day. Like, one section a day. And we'll start with this because this is the easiest, I think, to memorize. Helium. Sorry, hydrogen. Hydrogen, helium, lithium, beryllium. I'm sure there's a song about this somewhere. Hold on. Periodic. Ooh. Periodic table song. Surely. Ooh, yeah. Hold on. Everyone pause.
And now,
Let's hear it.
Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air.
Wow, I hate this.
And now,
At least I know the tune.
Science presents the elements of the periodic table.
There's oxygen so you can breathe for your breathing team. Light up the sign, sodium for salty times, aluminium, silicon, sulfur, chlorine, and argon, potassium.
Okay, we end at potassium, right? It's only 18. Yeah, it is. There's hydrogen and helium and lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. I forgot it.
Table.
There's hydrogen and
Helium and lithium, boron,
nitrogen all through the air.
I need lyrics. I need lyrics, buddy. I need lyrics. Alright, there you go.
The periodic table.
There's
Hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, fluorine for your pretty teeth, neon to light up the signs, sodium for a salty time, magnesium, aluminum, so you can resistance, sulfur, chlorine, and argon. Okay, there's oh my god. Okay. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, manganese, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Alright, let's try again. Oh. There's hydrogen and helium. That actually kind of helped a little bit. Fluorine. Oh, oops. Misclicked. Argon. Oxygen, neon, sodium, phosphorus, nitrogen. There's hydrogen, helium, as the lithium. It kind of helped. It kind of really helped, actually. Wow. Oh my god, it worked. There's hydrogen and helium and lithium, beryllium, boron, carbon everywhere. Nitrogen is in the air. Oxygen, I forgot already. Let's try again. Carbon everywhere. Nitrogen all through the air with oxygen so you can breathe. And fluorine for your pretty teeth. Neon to light up the signs. All the over salty times. Magnesium, aluminum, silicon. Let's read. Let's do all of it.
and calcium so you'll grow strong. Titanium, vanadium, and chromium, and manganese. This is the periodic table. No period will see new elements. Use the 26th in cobalt.
I need to add this to my dude. I swear. Okay, I took exercise physio last semester or last winter session, and there was a song there that really helped me, like actually really helped me pass the class. We're gonna go listen to it together while we how many people are watching? Probably not many, huh? Because it's really late at night. Absolutely no one. Oh yeah. I think I'm gonna go to sleep after this, but before I go to sleep, I'm gonna show you guys the song that I almost memorized. Almost. Alright, let's do it. Let's break it down. Glycolysis is a series of reactions, enzymatic actions, energy transactions. The fructose, a molecule of sugar, breaks it down for NADH, NADP. It's an anaerobic cytoplasmic pathway that amazes, organized easily into 3 phases: investment, cleavage, and energy harvest. Play later which one do you like best? Investment, activation, energy supplies, cleavage, our 6 carbon sugar divides. Harvest, we get our energy yield. So beautiful, so intricate. Keep your eyes peeled. Glycolysis. Come on, sugar for the breakdown. For the breakdown. Investments, like striking a match. With energy you put in makes the fire catch. For glycolysis, investments to ATPs, which act as activation energy. Enzymes take phosphates from ATPs, jam them onto glucose rearrange, you get to fructose, and fructose to Y6 bisphosphonated on the table. Phosphates, it's highly unstable, moving us to the second phase, the cleaving of fructose bisphosphate. I don't know why he says bisphosphate, but it's okay. 2 molecules of carbons 3, which I can't say anymore. DP exceeds on our pathway broken down for energy. Exactly when this enzyme will immediately get inverted into second G3P. I don't know that part very well, as you can tell. Come on, sugar for the breakdown. For the breakdown. G3P gets rearranged and oxidized by an enzymatic assembly line. With G3P, 1 NAH, and 2 ATPs. Sealed per G3P to 2 NAH and 4 ATPs. Sealed for ethylene glucosin. A generous clotting of glycolysis. That part goes hard. Invested in is 1, so you net just 2 that you can use to jump or run. Get 4 route, your net gain is 2 ATPs that you can use. If that doesn't seem like very much, because it ain't. Leaves tons of energy left in pyruvate. The 3 carbon molecules we're left with at the end. Pyruvate's gonna depend on the metabolic pathway where pyruvate set. Anaerobic, it'll be fermented. Anaerobic cells, pyruvate serenation, be the Krebs cycle, and total oxidation. Glycolysis. Come on, sugar for the breakdown. For the breakdown. Glycolysis starts with investment. ATPs to the glucose that we started with. Okay. Aerobic pathway is respiration's first phase. Evolved in ancient days. I love him. Before eukaryotic cells arrived on the scene, ubiquitous in every organism, imperious sequoiatry, no matter your metabolism. The cytoplasm don't need no looking at these dog glycolysis. Come on, sugar for the breakdown. For the breakdown. Literally, in this physio class, he says glycolysis is the hardest concept for students to grasp. And I was like, okay. I took that as a challenge. And so he recommended us this video to watch, like, after a lecture. And I was like, you know what? If it's really so hard to understand, I'm just gonna re-listen to this over and over and over again. And what do you know? Hold on. Pause. I found it on Spotify. And pause. Did I not? I'm like 100% sure I added it on Spotify. It might just be really far down. Where are you? There you are. January 4th, 2023. It's on Spotify. And so I just left this open while I was doing other stuff, and I would just memorize all of this. It's so good. Hold on, I know there's a karaoke version somewhere. Where is it? Ugh, God, it's somewhere here. Hey, those two I used in high school. This one I used in college. This one I'm gonna use now. Okay, hold on. Glycolysis rap instrumental. Alright, hold on. We're gonna leave. I'm gonna leave you guys off with this. Hold on. Hey, sugar. Come on over here, sweetie. Alright, let's do it. Let's break it down. Glycolysis is a series of reactions, enzymatic actions, energy transactions. Takes glucose and molecules agree, breaks it down for NADH and ATP. It's an anaerobic cytoplasmic pathway that remains organized easily into 3 phases: investment, cleavage, and energy harvest. Tell me later which one you like best. Investment, activation, energy supplied. Cleavage, our 6 carbon sugar divides. Harvest, we get our energy yield spot wrong. So beautiful, so intricate. Keep your eyes peeled. Glycolysis. Come on, sugar for the breakdown. For the breakdown. Investments, like striking the match, the energy you put in makes the fire catch. For glycolysis investments, 2 ATPs, which act as innovation energy. Enzymes take phosphates from ATPs, jamming one to glucose, you're rearranging it to fructose, leaving fructose 1,6-biphosphate on the table. With 2 phosphates, it's highly unstable. Moving us to the second phase, the cleaving of fructose biphosphate. Plus glycolysis means sooty sugar. You can see cleavage is 2 molecules of carbon 3. One is glyceraldehyde, 3-phosphate G3P. It continues on our pathway broken down for energy, but the second one, an enzyme will immediately convert into a second G3P. Glycolysis. Come on, sugar for the breakdown. The breakdown. Phase 3, G3P gets rearranged and oxidized by an enzymatic assembly line that harvests energy from each G3P, 1 NADH and 2 ATPs. Double this yield per G3P to 2 NADH and 4 ATPs. That's a gross yield for every glucosin. A generous accounting of glycolysis is when but 2 ATPs were invested in phase 1, so you net just 2 that you can use a jumbo run. Put 2 in, get 4 out, your net gain is 2 ATPs that you can use. If that doesn't seem like much because it ain't. There's a ton of energy left in pyruvate. The 2-3 carbon molecules are left at the end, and what's happened to pyruvate is going to have to depend on the metabolic pathway where pyruvate's. If it's anaerobic, it'll be fermented, but in aerobic cells, pyruvate termination will be the Krebs cycle and total oxidation. Glycolysis. It goes so hard, this beat. For the breakdown. For the breakdown. Glycolysis starts with investment of 2 ATPs to the glucose that we started with. The product is cleaved into 2 GTPs, from which each cell harvests energy. This anaerobic pathway's respiration's first phase, but it's a useful revoltation before you. Oh my god, my tool just ran across the room. Before eukaryotic cells arrived on the scene, it's everywhere, ubiquitous in every organism. Bacteria, sequoia tree, no matter your metabolism, happens in the cytoplasm. Don't need nothing else. If you want to fight glycolysis, they're fighting. Come on, sugar. Why are there blanks? Glycolysis. His other songs don't hit as hard, to be honest. This is the only one that's really good, in my opinion. I also had these ones. I'm gonna get copyrighted, but it's okay. This one goes hard too. It's... uh-huh. Hey. Okay. I like this one was okay, but I like this one a lot more. This one's I love this one so much. It's so good. I literally can't. Look at him jamming. Okay. The DNA starts to unwind. This is the key to making love. Without the copy cells are about to die. Genes go left unread. All my cells are dead. If my genes go left unread, all my cells are dead. If my genes go left unread, look at everyone's so hyped. I'm gonna freaking vibing, bro. Hey. Oh, okay. Yeah. It's not actually really showing anything. It's just love accepted up as twice. It's so good.
genetic cells, the cells that make up all of me. Separating my sex organs that help my cells take half of me. Yeah. The DNA
Starts alive. Our name is the other side.
Meiosis is the key to making life. Mitosis copy cells about to
Die. All my cells are dead. If my genes go left
unread, all my cells are dead. Yeah. If my genes go left unread,
I wish you guys can see me right now. I'm bobbing my head.
all my cells are dead.
Hey.
Apoptosis, make sure I don't spread. Mutations are results of genes misread. Transcription, RNA polymerase.
Hey. Okay.
Initiates, elongates, then terminates. Translate ribosomal units. Need free amino acids just to do it. Chromosomes made of genes makes the colors of our eyes and gives us a widow's peak. Oh, meiosis gives us very.
Anyway, you guys get it. We're done. We're done. We're not doing this anymore. Here, we'll leave with this. We'll leave with this song. Play.
Break it down.
Glycolysis is a series of reactions.
Enzymatic actions, energy transactions. Takes glucose, a molecules of sugary, breaks it down to NADH and ATP.
It's an anaerobic. No, we're not doing it again. Thank you guys so much for watching. You know what? Surprisingly, I didn't get everything done. I didn't expect to get everything absolutely done, but I got quite a lot done. All of this work that I got done today, like right now, was what I was gonna finish later today. Like later today as in Sunday afternoon. Like yesterday was supposed to be yesterday as in Saturday was supposed to be like my physics day. And then today was the day where I would do everything else. So hey, I got a jump start. Heck yeah. Anyway, thanks for watching. I'm gonna go now. It's very fun. Had fun studying. Had even more fun rapping to the glycolysis. This song really just genuinely goes so hard. I can't. I'm going now. Good night, guys. Good night, everybody. Sorry for no jackbox. It doesn't seem like anyone's online. Actually, I might be lying. Yeah, it seems like no one's online. But I'll see you guys. I'll see you guys another day. Mwah! G3P.
Come on, sugar, for the breakdown. For the breakdown. Phase 3, G3P gets rearranged and oxidized by an enzymatic assembly line that harvests energy from each G3P, 1 NADH and 2 ATPs. Double this yield per G3P to 2 NADH and 4 ATPs. That's the gross yield for every glucose in.